Pum pum pum. Oh hey, what's up? Gleb, Alexandrov here. Welcome to yet another very exciting creative frame tutorial. Have you ever wondered what if you could turn your CG animation into stylized art in kind of an instantaneous way? Now that's actually real. There's a free software by Secret Weapons called EbSynth, which does exactly that. It takes an image sequence as an input and a stylized keyframe as a kind of a guide, and then it intelligently propagates the artistic style of this keyframe to the entire footage. Kudos to Karol from 2 Minute Papers YouTube channel for introducing us all to this amazing tool. Alright, the first step would be to get an image sequence somehow. In my case, I will render it out in Blender 2.80. Of course, you can take the sequence from your favorite movie or whatever, but I think it would be nice to render something out and then stylize it using EbSynth. So what I'm doing here is adding a few keyframes to the camera location. I'm just pressing I and then selecting location. When I'm going to scrub through the timeline, move the camera a little bit to create some kind of a panning or zooming in animation. Press I again and select location to add the location keyframe to the end point of the camera movement. So our animation will end at frame 125. And I wonder if you agree that the scene looks gorgeous. By the way, it was created for polygon.com, the texturing website that you're probably familiar with. Okay, and due to the nature of EbSynth, we can use any image sequence we like. Once again, we can use cycles as our render engine of choice or Ebi. I'm gonna stick with Ebi because it's, well, faster. And to make it even faster for the test purposes, I'm gonna set the resolution to 50% of 1080p, which will result in roughly 960 pixels wide or something like that. The frame rate will be 24 frames per second. And lastly, I will select PNG as our output file format. Currently, EbSynth only supports JPEG and PNG format, where PNG is a lossless format and JPEG obviously a lossy one. Anyway, we export everything into our video folder, and naming is important. So in the end, hopefully we will have 125 PNG frames at 50% of the 1080p resolution output in our video folder. Eevee renders so fast. And the next thing after we're done would be to create a proper folder structure, because it's very easy to get confused with all these folders and files. So I will create a video folder. That will be our source footage. And the next folder will be named keyframes. It will hold keyframes. And the third one will be named mask. So in order to synthesize a stylized video, we need to provide EbSynth with a proper keyframe. And the proper keyframe is the keyframe that, according to the software creators, reveals as much as possible of that scene in that sequence. So I think the frame 20 is pretty much representative of the scene in that particular case. I will pick it as a keyframe. So I will copy-paste it into the keyframes folder. Here it goes. That's it. The keyframe is selected. Now we have to paint it. We can paint it by hand, and that's what I'm gonna do now. I will just drag and drop it into Krita, the free image editing tool that I absolutely love. And next I will embarrass myself by trying to create a quick paint over. I'm using a cheap Wacom tablet, by the way, but it gets the job done. And in the end, it will look extremely satisfying. I mean, after running EbSynth, you will see. And honestly, I almost fell out of my chair. I couldn't believe what I have seen. Especially if you keep watching and watch till the end of the tutorial, which I recommend you to do, you will see something extremely mind-blowing. Okay, after we've finished our painting, we can export the result, and I will just replace the initial keyframe, which probably is not the best practice, but it will do the trick. And we have all the source files in the video folder anyway. And it's important to give the keyframes the proper names that correspond with the frames of the initial sequence. Now let's have a look at the EbSynth user interface and its settings. I just downloaded the EbSynth from their website, it's free. So here we have the project directory, which will get filled in automatically after we drag the video into the respective field, or we can just press select. And you can see that the folder got assigned automatically. We need to do that with the keyframes folder as well. So just click and drag and place it over the keyframes over there. And the third input that we have here is the mask input. It's turned off at the moment and we will talk about it later on. It's just a feature, it's not a requirement, so we can do without it. So in order to hit the synth button and start processing the sequence, we have to define the left stop, which is the starting frame of the sequence, the keyframe, and the right stop, which is the last frame of that sequence. So 125, the starting frame, the keyframe, and the end frame. It's extremely important to have the file names sorted out and named in a proper way. And what I have discovered is that EbSynth doesn't like the 0000 type keyframes, and some software like After Effects outputs the 0000 type keyframes by default. So if you happen to have this type of keyframe, just delete it. And also make sure that you actually have the keyframe that you define over here in the respective folder, which is unsurprisingly named keyframes in our case. And just to remind ourselves, we have chosen keyframe number 20. So let's hit the synth button. Hopefully that will start the process and we will be able to watch how the new files keep popping up in the default out folder. That means that we can probably take a short break while it renders. But anyway, after it rendered, how to preview the result? We end up with this sequence of PNGs. Oh, by the way, let's take a look at them. If everything went right, you will see something like that. And actually, when I first saw the sequence and tried scrubbing through it, and I saw the art style propagated to all the frames in that sequence, and it was also extremely stable. It blew my mind. So if we want to recombine it into a video file, we can do it in numerous ways. What I will do is go over to Blender once again, switch over to the video editing layout, and enable the movie clip editor instead. And now I'll just load in a bunch of PNG files into it. Hit open, navigate to the out folder, border select over all files, and hit open clip. Done. And oh gosh, it seems that I forgot to disable the color management, but it doesn't matter much in that case. We have our PNG sequence playing in the editor here. Let's just make sure that the end frame corresponds with the end frame of the image sequence. I must confess that I almost never use Blender for processing video. But it's a fun experiment for me. So I'm gonna select the video output, let it be FFmpeg video, so we can select the codec as well as the video format. So let's open up the encoding tab and select the container, which will be MP4 because it's easily shareable on Twitter and stuff like that. And I want to share it with you guys. And as for the codec, let it be the default one, H264. And as the last step to make it absolutely readable for the future generations, I will create a new folder called Final Video and will output the video into that folder. One thing to keep in mind though, is that in order to be able to render animation through that menu, we would need to go over to the video sequencer. And over here, you can just click here and select video sequencer, then go Shift A over that part of the screen and select our clip. I'm gonna move it all the way to the left to make sure it starts from the first keyframe and ends at 125 as it should. And now we're fully prepared to compile this set of PNG images into the video file by going render animation. And here ends our segue into the Blender video editing capabilities. Thank you very much everyone involved in Blender video editing development. So here we've got our PNG file. The animation looks bananas, but I would prefer it to be a little bit more stable, and we have a special setting for that. If you jump over to the Advanced tab, you will see the deflicker setting here, and the default value is 0.5. We can take it slightly higher, or actually 10 times higher, and we will check if the video becomes more stable this way and doesn't explode. And I will also output it into a slightly different folder, because the last thing that I want is to overwrite the already rendered files. So let's create a new folder and output it there. And I will fast track through the video compilation process. Here we've got way more stable result thanks to the deflicker setting. I have such a strong impression that the paint layer just sticks to this 3D surface. It predicts the movement of pixels in such a cool way. Now let's go ahead and crash test EbSynth with a slightly trickier sequence, which contains a few subsequences stringed together. The source footage has been rendered in cycles, if you're interested, and it has a lot of depth of field and flickering. Let's see how EbSynth handles that. As we recall, we should pick the proper keyframes first. I will pick the ones without heavy depth of field, because I guess it will be much easier to blur the image if you wear the EbSynth algorithm than to de-blur it. The next thing I want to do to keep things organized is to somehow mark the start and end frames of each subsequence. I'm just hovering over the image sequence and trying to see the cuts. So for example, the subsequence 2 ends at 241st frame. Yeah, you got the point. It can be a little bit tricky to keep these figures in memory, so what I'm gonna do is to write it down. As simple as that. So for example, here are our 3 chosen keyframes, one for each subsequence, and here is my notepad file, and I just wrote down the main figures, the main numbers, to what sequence each keyframe does correspond. Because the synthesis process could take quite a long time, it's better not to screw it up. Alright, so now we have to stylize the frames somehow, the keyframes I mean, and how about trying something different, like Deep Dream Generator, a neural networks based style transfer algorithm that works with the still frames. Don't mistake it with the video-based algorithms like EbSynth. So we will do a double stylization. First, we will stylize the still frame, and then with the help of EbSynth, we will propagate the chosen artistic style to our footage. So in the Deep Dream Generator, which is free if you use the low resolution settings, something like that, we can choose from a selection of default presets as well as the popular styles. For the image processing, we can choose, for example, Starry Night by Van Gogh as a guide for reimagining our source content, which is amazing by itself. And as I've said, this online resource has a limitation in terms of resolution for free accounts, something about 5 dreams an hour for the newbie account. Never mind, it will be sufficient for what we are going to do, and the low resolution won't matter much as well. It takes a while to process, and look at that. How about that? It's a perfect marriage of the source render and the Van Gogh's Starry Night. Whoa. Let's save the keyframe and name it correctly. It was the keyframe 26 in this case. After that, we can just reuse the style on the rest of the images. Upload the image. Select another keyframe, OK. And I ended up using a slightly different artistic style for the video. And I wonder if you agree with me that this dip style transfer algorithm creates something that looks far more convincing than your usual filter in the image editing software. I think it's really something else. It's not just a filter, that's a very important distinction. And one quick thing we should take care of before launching EbSynth is resolution. Because Deep Dream Generator output the image in slightly lower resolution than it initially was, we need to compensate for that. I will just crank up the resolution in Krita to make sure it lines up with the initial resolution of the source images. And then I'll hit export, and I will replace the keyframes with the new resized versions. If it was an actual production, I would prefer to retain an original resolution, but who cares? It will do the trick. Though I think that some machine learning based super resolution algorithm would do a much better job. But anyway. Next we'll have to deal with the multiple sequences in EbSynth, but thankfully it's a relatively easy process. If we have sorted out our files in their folders, like video keyframes, we can drag it into the video in keyframes fields. And here is our cool notepad file, very useful file with the data. We can just input it over here. For the subsequence number 1, the starting frame will be 1, the end frame 120, and the keyframe 26. Now we can hit plus and input the data for the second subsequence. It will start at frame 121 and at frame 241, and use the frame number 154 as the keyframe. And I will just type in the rest of the sequences. And after doing that, we should define the output folders. And the important thing to consider is that if we don't have overlapping frames in our subsequences, we can dump everything into just one folder. But if we do have overlapping frames, actually we will talk about that a bit later on. Now we can just hit the Run All button after we set everything up, and notice how the freshly generated files keep popping up in the output folder. That is so nice to watch when everything works, when the keyframe was picked just right. And as you can see, despite the fact that the input content was rendered with lots of depth of field and flickering, the end result is again nothing but mind-blowing. Honestly, that's how I would describe it. As far as I understood, this software doesn't use any kind of artificial intelligence or neural networks. It's an example-based generator. The algorithm has some temporal awareness in the sense that it doesn't create each frame independently. Because of that, it doesn't introduce chatter and flicker into the final result. Right here I saved the EBS file in case I would like to try a different art style, so we won't have to bother ourselves with this setting up process. Okay, and the third input that EbSynth understands is mask. Just like we might have expected, the mask, the black and white mask, defines the area of the image that will be affected by the processing. And on top of that, the final result will be available with alpha. In case you would like to compose the background separately, to be able to render the black and white mask in Blender 2.8, I will switch the viewport over to the solid mode, switch the background over to world, and we should make sure that the color of the background is black, 000 RGB, and the lighting should be set to flat, because we don't want to see any kind of shading, we just want the flat black and white image. The material color should be 1.1.1 RGB, that means white. I will also disable the outlines, we don't really need to see the outlines, and it looks to me like it may work, we just have to render it out somehow. As it's the viewport rendering, we should go to the View tab, and then go Viewport Render Animation. Don't confuse it with the Render Animation tab at the top. That's a completely different thing. So after the viewport rendering is done, we should enable the mask by hitting the off button. It will turn to on. And now we can plug the black and white mask sequence into the mask field. Let's double check it. Here it is. Once again, the names of the files should correspond to the names of the source content. So we hooked up the mask over here, and here is a quick tip. If you want the output files to have transparency, to have the alpha channel, we have to make sure that our keyframe also has an alpha channel. Otherwise, you'll get a really weird result. So let's make sure that the keyframe has a transparent background, which corresponds to the mask. Yeah, as you already can tell, everything should correspond to everything. You should strive for 100% cohesiveness. That's a serious business. Just one mistake and you're done, comrade. So if everything went alright, after all our manipulations with the mask, we should see something like that. And what it actually means is that we can use different backgrounds, stylize it separately, using a different art style for that matter, and then compose it all together. To extend this fantasy a little bit further, what we can also do is use different frames per second settings for the background and foreground, like in Spider-Man Into the Spider-Verse. So yeah, it's great. We can do different creative stuff with it. I'm glad we have this option here. And again, I couldn't help but notice how exceptional is this synthesized result based on just one keyframe for that kind of footage. But what do we have to do if our input sequence really changes over time in the sense of content? Like this camera pan, for example, where the first and the last frame doesn't have anything in common. We just need 4 or 3 or multiple keyframes. But first, let's quickly show what happens if we use just one keyframe in that scenario. In some cases, it could work surprisingly well, but in most of the cases, if there are some objects in the scene that aren't included in the keyframe, it will just explode. It will just break down, like you see here. It doesn't look like it's catching up to the original content, like it's lined up with the content, and thanks goodness it didn't explode, because it could. So the solution that the creators of this software propose is to just select a bunch of keyframes that will together reveal most of the scene. So the idea behind that is that we have to render the scene a few times using different keyframes, and then in the post-processing we can blend between those processed sequences. So let's try to set something like that up. The start frame should be just 1 for each of the 4 subsequences. Again, the point is to render the same sequence using multiple keyframes to increase the odds of getting something decent in the end, and then blending between those resulting sequences. As you can see, I'm creating a bunch of output folders, one output for each sequence, because we have 4 overlapped sequences. We don't want to overwrite it. And again, it's crucial to not ignore the naming conventions. Here I named each folder after the corresponding keyframe, so we can remember which sequence corresponds to which keyframe. It will make everything so much easier, believe me. So after we fill in all the data, we can then increase the deflicker, because I know it will be flickering. I'm setting it to 2 and hit the Run All button. When you have multiple footages and multiple keyframes, it can really take some time, but hopefully in the end we'll have something like that. 4 sequences overlaid on top of each other in your video editing software of choice. Blender! Woohoo! And then we can do whatever we want to do, really, to get more or less smooth transitions. For example, what I'm trying to do here is find out where the cut should happen from one sequence to another based on the keyframe number of that sequence. And then I'm going to simply use opacity. I'm going to keyframe it from 0 to 100 to smoothly blend in the sequences one by one. To keyframe the opacity setting, first make sure that the right panel is on, and then set opacity keyframe to 0, right click, insert keyframe, scrub the timeline, like for example over here, and change the opacity key to 1 and insert yet another keyframe over there. I realized that it must be the most primitive way of blending animations together, but it gets the job done. Probably the much better way would be to morph footages, and there are rumors that in some future version of EbSynth there will be a feature that will allow us to automatically blend between different keyframes. That would be exciting. Just imagine. Okay, and before we call it a day, I want to show you something exceptional. If you're into 3D rendering, your mind will be blown. Let's use this metaphor for the third time. Nobody cares. So, as you might have guessed, we're gonna render the checkerboard scene in Eevee. And after that, we're going to render just one frame in cycles with full textures, materials, lighting, all boxes ticked. And honestly, I thought, no way it could work. No way on earth that could work. But hey, look at this. Somebody tell Carl from 2-Minute Papers to make sure he falls out of his chair. Basically, just to describe what happens on screen, EbSynth treats the cycles render as a kind of an art style, and it extrapolates that art style on the checkerboard footage rendered in Eevee. Holy moly. Oh, thanks for watching. I hope you enjoyed that tutorial, and it was mind-blowing, and it was a little bit useful, at least. I hope it was mind-blowing, really, but you never know. Consider supporting the EbSynth developers by spreading the joy of EbSynth. The tweet about it would be great, especially if you attach something awesome to it. I want to plug a quick cross-promotion here because my friend Eugenie has released very similar tutorial, and he released it in Russian. So if by chance you want to watch it in Russian, now you have options. Options are great. Anyway, my name is Gleb Alexandrov. Make sure to thumbs up this video right now to make it rank higher on YouTube. Drink more coffee, and we will change the world of computer graphics one day.